Come in.
Happy Valentine's Day.
Thank you. Now, if I dunk the rose into liquid nitrogen, 196 degrees centigrade, nearly minus 200 degrees centigrade, when you break it, it makes a sort of satisfying clonk. From a chemist's point of view, one of the most interesting things about chocolate is its melting point. Chemically, mixtures often have rather ill-defined melting points. They don't melt all at once. But with chocolate, it's different, and it has a very sharp melting point. So the chocolate in your hand doesn't melt, but as soon as it goes in your mouth, which is only a little bit warmer than your hand, it melts, and it melts very sharply to give a rather smooth, smooth liquid, which gives it this very sensual flavour in your mouth, or sensual feel. Another big part of Valentine's Day are roses, and flowers in general, but particularly roses, and particularly red roses. The smell molecules are really, or fragrance I should say, it's a politer word for a nice smell, are really quite simple molecules. They are very volatile, they vaporize very easily, so they go into the air and you can smell them. So that when people are collecting the fragrance from roses to make perfume, for example, they have to collect the roses early in the morning before the sun has heated them up and all the smell has evaporated. Then usually, in the old days, they extracted this fragrance using hexane, which is like a light form of petrol. Hexane is more volatile, it evaporates more easily than the fragrance molecule, so it dissolves them out, and then you can allow it to evaporate, and you're left with the smells and the waxes that come out of the roses. My favourite piece of chemistry comes with these mints. You've probably all seen these rather thin mints, which have chocolate on the outside, but if you break them, you can see inside they're all soft and gooey. So think for a moment, how is it possible to put such a nice layer of chocolate over something that is so gooey and liquid? And it's done with a very neat chemical trick, because the inside of these chocolates, when they're made and coated, is made out of sugar. Now, when this is mixed up, you can make really quite a stiff paste. It's essentially a solid. But it is mixed with a naturally occurring enzyme called invertase. And when the chocolate coating has been put on, and it's already put into the box, a chemical reaction starts between the invertase and the sugar. The molecule of sugar consists of two rings joined together by an oxygen atom in the middle. And the invertase splits these two rings apart to make two other sugars, fructose and glucose. And when these are mixed together, they give you this sort of liquid. And the longer you keep the mints, the more and more liquid it gets. So I'm not a specialist in the colours of roses, but you can see that you can get red ones and you can get all sorts of different coloured roses which have been bred to give these different colours. Now, as a chemist, I know that these colours are all due to organic compounds. These are compounds of carbon, which might have a little oxygen and nitrogen as well. But the colour is usually associated with a string of double bonds between the two carbon atoms. Carbon atoms can be linked, usually are linked with just a single bond between two atoms, but sometimes you can have a double bond, and occasionally you can even have a triple bond. But a line of these double bonds will give rise to colour, and the longer the line of the double bonds, or the chain of double bonds, in general, the more the colour shifts towards the red. Different molecules will have different colours. Now, it's my personal feeling, and this is just a guess, but I think it's very unlikely that people breeding roses can suddenly persuade a rose to produce a completely different compound. So it's much more likely that the rose colour is due to a mixture of several compounds, each of which has a slightly different colour. If you stop the rose producing any compounds, it will be white. But if you alter the proportion, then I think that you can get these different colours like orange or yellow or deep red. So selective breeding will allow you to vary the proportions. But none of these compounds is blue, which is why without genetic engineering or something more clever, you can't make a deep blue rose because the colours are just not in the palette. Chocolate contains a compound called theobromine, which is very similar to caffeine. The difference in structure between caffeine and theobromine is just the position of one group containing carbon and 3 hydrogens. So chemically they're quite similar. And so that the effect of theobromine is also to heighten the effect of eating the chocolates. But theobromine is a stimulant and it is forbidden for racehorses. So if you feed a chocolate bar to your racehorse, if you're rich enough to have one, then if the horse wins the race, it may be disqualified because they can detect theobromine in the horse's urine when they do a drug test. Roses are quite amusing for chemists because you can do quite a nice trick with them. Now, if I dunk the rose into liquid nitrogen, which is at minus 196 degrees centigrade, nearly minus 200 degrees centigrade, the nitrogen starts boiling and the cold gas comes out, and nitrogen is completely colourless, but the cold gas condenses water vapour, so you see what looks like white smoke. So if we take it out now, it's gone quite brittle, so you see if I just bang it, it now breaks into little pieces. Because the water in the leaves, or in the petals, have frozen. So I'm not sure why people use this expression that the chemistry is right. I think it's because in chemistry, different atoms and different compounds combine together to form really stable molecules or complexes. So just in the same way, if you get the right two people, they will react together and give a very stable combination. Some of the others may give something that's a bit more volatile, or occasionally a pairing that's even explosive. But that's what makes chemistry fun, and it's what makes relations fun as well.